Okay guys, today we're going to take notes on chemical equations and the law of conservation of mass. So a chemical equation is a short way of writing a chemical reaction. The equation uses the element symbols and the chemical compound formulas instead of actually writing the full words. So instead of writing out water molecule, it's just going to write H2. So a chemical equation is a way of writing a chemical reaction in words using the symbols. So let's talk about the parts of a chemical equation. Reactants. These are anything that you are going to find on the left of the arrow, and they are the substances that you are starting with. They're the chemicals that you are mixing together, and they're what are going into the reaction. Products are going to be found on the right side of the arrow, and they are the new substances that are being created, and they will be coming out. So just remember, reactants are what go in, and products are what come out. Now, instead of writing an equal sign when we do chemical equations, we always put an arrow, and the arrow means yields. Yields means to make, like an equal sign on a chemical equation. So let's look at this chemical equation we have right here. You have your reactants, which are C and O2. Then you have your yield sign, which means the actual reaction is occurring. And then you have your products, or product, which is CO2. Carbon dioxide. So on your chemical equation, you will always have your reactants, which are going to be on the left of the arrow, and they're what go in. And your products, which you make, are going to be on the right, and they're what come out. So in other words, the equation says one carbon atom reacts with two oxygen atoms to yield or make one carbon dioxide molecule. So that's how you would read it in words. But instead of writing it out, we just write C plus O2 yields CO2. So remember, every chemical equation needs to have a wrap, a reactants, an arrow, and a product. So write that down. So look at this chemical equation we have here. Now instead of giving you the chemical formula, I've drawn it, but could you still write the chemical equation? Just like when we did chemical formulas, and I would give you the formula and you'd have to tell me the number of atoms, molecules, and elements. Now I could draw a picture. Could you still give me the chemical equation? So let's talk about the difference between a chemical formula and a chemical equation. A chemical equation is made up of different chemical formulas that will either be separated by a plus sign or the yields arrow. So write the chemical equation for this reaction using the symbols. So it would be H2, because you have two hydrogen atoms connected, plus 1O yields H2O. So if you were going to write this equation as a sentence, it would be two hydrogen atoms react with one oxygen atom to yield or make one water molecule. As you can see, this is a lot more to write, and that is why scientists use the chemical formulas and the symbols. It's faster, and scientists are lazy. So let's talk about the law of conservation of mass. The law of conservation of mass states that mass cannot be created nor destroyed in a chemical reaction. And what that means is that the total mass of the reactants is always going to equal the total mass of the products of a chemical reaction. Meaning that if you have one hydrogen atom go in, you have to have only one hydrogen atom come out. That hydrogen atom cannot be converted or turned into an oxygen or any other type of element, because that is creating and destroying matter and mass, and that breaks the law of conservation of mass. Therefore, in order to model a natural occurrence of a chemical reaction equally and accurately, the equation has to be balanced. And to have a balanced chemical equation, that means you have to have the same number of atoms of each element on each side of the chemical equation. And remember, what are the two sides? You have the reactant side and the product side. So consider the following balanced chemical equation. You have 2Na plus 2 HCl yields H2 plus 2 NaCl. If you were to draw a line right through the arrow, and go ahead and do that on your notes, label the left side as the reactant side and the right side as the product. You have to identify the elements involved in the equation. So looking at this, we have sodium, hydrogen, and chlorine. If you look on the product side, again, you have sodium, hydrogen, and chlorine. They're not in the same order, but that doesn't change anything. Now, after that, you need to count the number of atoms of each element. So how many atoms of hydrogen are there in the product side? There are 2. How many molecules of HCl are there on the reactant side? 2. And how many molecules of H2 are there on the products? 1. Do not forget, if you do not see a coefficient, the answer is always 1, never a 0. And finally, how many atoms of sodium are on the reactant side? And the answer is 2. So to check if this equation is balanced, if you'll notice, you have 2 atoms of sodium go into the reaction, and you have 2 atoms of sodium come out. You have 2 atoms of hydrogen go in, and you have 2 come out, meaning that it is a balanced chemical equation. The mass was not created nor destroyed. They just moved around and changed their bonding. So as a review, because after your post-test or your quiz today, y'all didn't do very well on this section, how many atoms of H are in 3H2O? And there's 6. How many molecules of 3H2, which is water, are there? And again, if I say molecules, that means coefficient, so it's 3. So let's practice balancing if an equation can be balanced or not. So what makes an equation balanced? The same number of atoms on the reactant side has to be the same number of atoms on the product side. And how can we prove an equation is balanced? Well, you're going to need to count the number of atoms for each element and make sure the number does not change. So count the atoms on both sides. If the number is the same, then you know the equation is balanced. If it is different, then you just simply state that the equation is unbalanced. So let's look at these equations. All right, the way I'm going to want you to do this, and I'll walk you through it in class, is the first step is always draw a line through the arrow. That way you're dividing your reactant side from your product side. Second thing is I want you to list all the elements involved. So it would be phosphorus and oxygen, phosphorus and oxygen. Then the third step is count how many atoms you have. So I have 4 phosphorus going in and 10 oxygen coming out, and 4 phosphorus coming out and 10 oxygen coming out, meaning that this equation is balanced. Okay, so go ahead and do that on the second equation and pause the video. So make sure you did all your steps where you drew the line, listed your elements, and then counted them. Notice you had 2 chlorine going in, but only 1 chlorine coming out. So that is not equal. Automatically right there, you know the equation is not balanced because you cannot destroy matter. You had 1 sodium go in, 1 come out. 1 bromine go in, however, you had 2 come out. So even though sodium is balanced, your other elements are not, meaning this equation is unbalanced. It does not follow the law of conservation of mass. So it would not actually happen in reality because all chemical reactions naturally follow the law. Okay, I want you to do these 2 chemical equations as well, and I will check them first thing in tomorrow. So make sure you're doing your steps, drawing the arrow, listing the elements, and counting the atoms. And then off to the side, just tell me if it's balanced or unbalanced. Okay, so when you come in tomorrow, open your journal to this page.